Hello. So for this part of the videos, we're going to be dealing with number bases. So as one of the last subtopics under real numbers. So mostly the first part is converting numbers from one base to another. Mostly bases below 10. So 2, 5, 10, 3, 4. And then the next part is operations in number bases from base 2 to base 10. That's subtraction and addition. So for number bases, the first one is about dealing with changing from base 10 to other bases, right? So an ordinary number, let's say if we're given a number like 15, this is the same as saying 15 to base 10. We don't usually write the base 10, but it's always there for any ordinary number. If the base is written, then usually it's not base 10. So for the order of operation, to change from base 10 to another base, you divide the base 10 by the new number, then you continue dividing until 0 is reached, writing down the remainder each time. So then after that, you start with the last remainder, reading upwards to get the answer. So if, for example, we are given change 16 to base 4, right? So what you do is you make a column, like a table of sort, where you have the base, the number, and the remainder. You can almost so you need to just keep track of that. So for the first part, we know that the base is 4, the number is 16 that we're starting with. So then you say 4 into 16, that's going to be 4, and the remainder is 0, and then you write the remainder down here. The remainder is 0. Next, so that's 4, right? 4 into 16. Then 4 into 4, that is 1, and the remainder is 0, right? And then 4 into 1, so 4 into 1, that's going to be 0, and the remainder is 1. And then what you then do is you read the remainders from the bottom up. So then your answer becomes 16, which is the same as 16 to base 10, is equal to 100 to base 4. And then the next one, change 27 to base 5. So again, you have your base, your number, and the remainder. And we're changing 27 to base 5. So 5 into 27, that's 5, since 5 times 5 is 25, and the remainder is 2. 5 into 5, that's going to be 1, and the remainder is 0. 5 into 1, that's 0, and the remainder is 1. So once we have reached 0 here, then we read all remainders from the bottom up, such that we know that 27 is the same as 102 to base 5. And then we go to the next one, change 112 to base 8. So again, we have the base, we have the number, and we have the remainder. So the number is 112, the base is 8. 8 into 112, that's 14, the remainder is 0. 8 into 14, that is 1, the remainder is 6. 8 into 1, that's 0, and the remainder is 1. Which means that 112 to base 10 is the same as 160 to base 8. Then the next question asks us to convert 75 to in base 10 to base 5 and to base 2. So the first part is to base 5, right? So we have the base, we have the number, and we have the remainder. So we have 75. The base is 5. 5 into 75, that is 15. The remainder is 0. 5 into 15, that is 3. The remainder is 0. 5 into 3, that's 0. The remainder is 3. And then, since we have reached 0 on the numbers, we then read the remainders from the bottom up. And our answer is 300. So 75 base 10 is the same as 300 to base 5. Now the other part asks us to change it to base 2. So again, we have the base, we have the number, and we have the remainder. So it's 75 to base 2. 2 into 75, that's 37, remainder 1. 2 into 37, that's 18, remainder 1. 2 into 9 into 18, that's 9, remainder 1. 2 into 9, that is 4, remainder 1. Oh, sorry, 2 into 18, that's 18, remainder. 2 into 18, that's 9, remainder 0, sorry. 2 into 4, that is 2, remainder 0. Sorry, I think let me just restart this one. So we have 2, we have 75. Okay, 2 into 75, that's 18, that's 37, remainder 1. 2 into 37, that's 18, remainder 1. 2 into 18, that's 9, remainder 0. 2 into 9, that is 4, remainder 1. 2 into 4, that is 2, remainder 0. 2 into 2, that is 1, remainder 0. 2 into 1, that's 0, remainder 1. So what that means is 75 to base 10 is also equal to 1001 0 1 1 to base 2, because now we are reading from the bottom up. Great. So you can give a try to these few questions extracted from the New General Mathematics textbook, mostly changing numbers from base 10 to base 5 or 2. And the next part is about changing from other bases to base 10. So, for example, we are given 321 to base 5, change it to base 10. So what happens is you have to expand using the base. So expand using the base to its powers. And then you simplify. So when you expand, the powers start from 0 up. So to its powers, right? From 0, increasing, right to left. So we have 3, 2, 1 to base 5. So what that means is we say right to left, right? So right so that's going to be right to the left. And that means that this is to the power 0, to the power 1 and to the power 2, because then basically the powers are increasing from the right to the left. So then if we're starting from the right to the left, this expands to 1 times 5, which is our base, to the power 0, plus, then in brackets now it's 2 times 5, our base, to the power 1, plus 3, which is the third number, times 5 to the power 2. So if you can notice, here we have to the power 0, to the power 1, and to the power 2. It's increasing, and these are the same numbers, 3, 2, 1, and that's it, 3, 2, 1. So take note of that. And then once we expand this, 5 to the power 0, that is 1. 1 times 1, that is 1. Okay, let me just write 1 times 5 to the power 0, that's 1. And the number to the power 0 is 1. Plus 2 times 5 to the power 1 is 5. Plus 3 times 5 to the power 2, that's 25. Since it's 5 times 5, that is 25. That's going to be 1 plus 10 plus 75. And that's going to be 86. And that's how we get the answer. So for the next question, we have 216 to base 8. Change it to base 10. So again, from the right to the left. So from the right to the left, increasing powers, that's going to be 0, 1, 2, which will be equal to 6, the first number, times 8 to the power 0, plus the next number, which is 1, times 8 to the power 1, plus the third number, 2, times 8 to the power 2, which is going to be equal to 6 times 1 plus 1 times 8 plus 2 times 64, which is equal to 6 plus 8 plus 128. And that translates to 142. And yeah, then the next question, it says change 1011 base 2 to base 10. Again, expanding to base 10. You know that from right to the left, it's going to be power 0, 1, 2, and 3 of the base. So that's going to be equal to 1 times 2 to the power 0 plus 1 times 2 to the power 1 plus 0 times 2 to the power 2 plus 1 times 2 to the power 3, which becomes 1 times 1 plus 1 times 2 plus 0 times 4 plus 1 times 8, which becomes 1 plus 2 plus 0 plus 8, and that adds up to be 11. So that's it. So if you could try, I can also expand the following examples. So it says expand A and B in powers of their bases. So A is 25,024 to base 8. So again, from right to left, we write the powers on top. So we're going to start from 0, 1, 2, 3, and 4. And that expands to 4 times a to the power 0 plus 2 times a to the power 1 plus 0 times a to the power 2 plus 5 times a to the power 3 plus 2 times 8 to the power 4. And that becomes 4 plus 16 plus 0 plus 2560 plus 8192. Adding that up becomes 10,772 to base 10. And the next one, B, is 1001 to base 2 to be expanded to base 10. So again, 0, 1, 2, and 3, and that becomes 1 times 2 to the power 0 plus 0 times 2 to the power 1 plus 0 times 2 to the power 2 plus 1 times 2 to the power 3. And that becomes 1 plus 0 plus 0 plus 8, which should be equal to 9 to the power 10. So if you could do the following exercises, the first one is expanding in the following powers of their bases. So expanding to base 10, and then the same one as well for number 2, for exercise 2. And then the next part is about adding and subtracting in base form. So this differs a little bit than what we would normally do when we're doing in base 10, in that you can actually do operations of subtraction and addition in the same base form. You just can't do it with a mixture of bases. You can't add something in base 2 to something in base 5 without converting them to the same base. But if they're both in base 2 or both in base 5, then you can add or subtract them. So for the first example we're given is 6,786 to base 9 plus 2,570 to base 9. And we're asked to add those two. So unless if the total of the addition exceeds 9 or is equal to 9, you just write down the number as is. If it's above, you write down the remainder. So how I'm going to explain that is in this case, okay, so the first one is 6 plus 0, that's going to be 6. It's less than 9, so that's okay. The next one is 8 plus 7, then that's going to be 15. Right? And we know that this is greater than 9 because 15 minus 9 will give you 6. And 6 is the remainder. So then what you then write is 6. But then you add 1 to the next number. So then you write 6 and then plus 1 up here. So now you have 7 plus 1, which is 8 plus 5, which is 13, right? So here you're going to have 13. Again, this is greater than 9 in that it's going to be 13 minus 9, which is equal to 4, right? Again, so you put down 4, which is the remainder, and then plus 1 here. And then you're going to have 1 plus 6, 7 plus 2. That's going to be 9. So 9 is equal to 9. So it's going to be 9. And it's going to be 9 minus 9, which is equal to 0. Then which means it's going to be plus 1 there. So here it's going to be 0, and then 1 plus 0 is going to be 1. So that means that the answer will be 10,466 to base 9. So you have to follow what you're adding on the next step, and that your number should not exceed 9, should not exceed the base, the number which is going to be in the final answer. Otherwise, you then say, what's the remainder after 9? And when you're subtracting, it's almost the same rule, only that you will be borrowing. Instead of borrowing 10, you're borrowing whatever base it is. So we have this example here, 2403 to base 6 minus 542 to base 6. So again, this one is 3 minus 2, that's going to be 1. 0 minus 4, that is going to be, you need to add to borrow something. So when you borrow 1, you borrow a 6. When you borrow something complete, in this case, you borrow a whole number. So borrowing from 4, that means this is going to be equal to 3, right? So 6 minus 4, that's going to be 2. And now that we borrowed 3 minus 5, that is also incomplete. So now you borrow from 2, such that 2 becomes 1. And then you say plus 6. So now I have 6 plus 3, that's 9, minus 5, that's going to be 4. And then 1 minus 0, that's 1. And then that means that it's going to be 1421 to base 6. Or I suppose when you do subtraction, this could be easier understood by what we almost do when we do general subtraction for numbers in base 10, where we say 3 minus 2, that's going to be 1. 0 minus 4, almost it can't, but then when you borrow plus 6, and then here when you borrow, this now becomes minus the one whole thing you borrowed, which is like a 6. So this becomes minus 4, this becomes 4, sorry, minus 1, right? Then 6 minus 4, that is 2. And then oh, sorry, when you borrow, you add to this. So 542, yeah, you add to this. So now this becomes 6. And then now this becomes 4 minus 6, it can't, so then you borrow another 6, and then here it is a 1, which is a whole number, right, which is like a power is a base 6, and then it becomes 10 minus, because 6 plus 4, which is 10 minus 6, that's going to be 4. And then two minus 1, that's going to be 1. Then you get the same answer. So for the next one, which says 1031 to base 5 minus 44 to base 5. So again, 1 minus 4, it can't, so you need to add a base 5. So because you've added here, that means that you've subtracted here, such that because you've borrowed from the previous 10th, or in this case you've borrowed from the previous 5, base 5, a whole base 5, and that's going to be 5 plus 1, 6, minus 4, it's going to be 2. 2 minus 4, then it can't, so now you need to borrow from the previous one, which is a 0, so you need to borrow from this, which is going to become a 0, to add here a base 5, and then here you borrow again so that it becomes a 4, and then you add here plus 5. So 5 plus 2, that's going to be 7 minus 4, that's going to be 3, and then 4 minus 4, 0, and then 0 minus 0. So then your answer is going to be 32 to base 5. Or the other way around, 1 0 3 1 minus 4 4 4 to base 5. 1 minus 4, it can't, so you add plus 5 here, and then here you also add plus 1, which is going to be 5 because you borrowed from the previous one, right? Then it's going to be 6 minus 4, that's going to be 2 base 5, and then again here 3 minus 5, it can't, so then you borrow from the previous one by adding plus 1, then here it's going to be 5, and then here it's going to be plus 5, so it becomes 8 minus 5, that's going to be 3, and then 0 minus 5, it can't, so you then add 1 here and add a 5 there. 5 minus 5, that's 0, so then that's why it becomes 32 to base 5. And then the next one is on addition. 345 to base 8 plus 453 to base 8. 3 plus 5. So the first one, 3 plus 5, that's going to be 8. So it's equal to the base. So it's going to be 8. And the remainder then 8 minus 8, the remainder is 0. So what we write is 0 here. The next one, 4 plus 5. Sorry, and then you also add the plus 1 here because you had added it, because now you're carrying the 1 from the 8 to the next one. So that's going to be 4 plus 1, 5 plus 5, that's going to be 10, right? So that's going to be 10, and the remainder is 2. So that's what you write here, 2. Then you carry 1 because it was more than 8. Then it's going to be 1 plus 3, 4 plus 4, it's 8 again. That's going to be 8. And the remainder is going to be 0. Then you carry 1 to the next place order. That's going to be 0. And then 1 to base 8. Then the next one is 2 3 2 1 to base 4 minus 1332 to base 4. 1 minus 2, so the first one, 1 minus 2, it can't, so then you borrow from here such that it becomes 1, then here you say plus 4 such that it becomes 5 minus 2, that's going to be 3. 1 minus 3, it can't, so you borrow again from this, which becomes 2. Here it becomes plus 4. 4 plus 1, 5 minus 3, that's 2. So that was this one. And then 2 minus 3, it can't, because now we're dealing with this part. So again, we borrow from these 2 such that it becomes 1 by adding base 4 to the next number. 4 plus 2, that's 6 minus 3, that's 3. And then that 1 minus 1, that's 0. So then it's 323 to base 4. So yeah, I think it can be a lot to understand, but it is the same format as you would do for base 10, just that you're not adding 10, a tenth of something, you're adding the base. You're adding of like base 4, you're adding base 5, depending on what it is, base 8, or subtracting. So now an example when the numbers have different bases. So in this case, we have 1,212 to base 3 plus 24 to base 5. Give the answer in base 3. So I would say the first thing, we have two different bases, right? And we have to deal with them. So the first thing is convert 24 to base 3. So how you do that? So it's 24 base 5. First you take it to base 10, then to base 3. Because you can only do operations in base 10. Or if you want to convert both of them to base 10 and then convert the answer to base 3, that's another way to go about it. So first convert 24 to base 3. So 24 base 5. So what that becomes is 24 base 5. Going back to how we expand, you know that this is going to the power 0 to the power 1, which is going to be equal to 4 times 5 to the power 0 plus 2 times 5 to the power 1, which is going to be 4 times 1 plus 2 times 5, which is equal to 4 plus 10, which is equal to 14, right? Now you have to convert it to base 3. So now you have again base, number, remainder. The base, now what you want is base 3. The number is 14. 3 into 14, that's 4. Remainder 2. 3 into 4, that's 1. Remainder 1. 3 into 1, that's 0. Remainder 1. So now you have 112 base 3, right? Then the second part is to add the numbers in base 3, since now they're both in base 3. So the first one is 1,112 plus 1. So now it becomes 1,212 base 3 plus 112 base 3. Again, you put it in abacus form, which is 1,212 base 3 plus 112 base 3. 2 plus 2, that's 4, which is going to be greater than 3. So that's going to be greater than, the remainder is 1. And then you add 1 to the next one. 1 plus 1, 2 plus 1, that's 3. That's 3, which is greater than 3. So the remainder is 0. And then you carry 1. 1 plus 2, that's 3. Plus 1, that's 4, which is going to be 4. Remainder, the 4 minus 3, that's going to be the remainder of 1. And then you carry 1. 1 plus 1, that's 2, which is less than 3. So that's just going to be 2. So then the answer, the final answer is 2,101 base 3. Cool. And then the next one, we have 48 base 8 minus 1,101 base 2 in base 7, right? So convert both to base 7. So again, it's 48 base 8 to base 10, and then to base 7. No, oh, in this case, okay, sorry, to base 10 first, and then no, convert both to base 10. Yeah, so I'm choosing to do convert to base 10, computing, and then converting both the answer to base 7. Okay, so to base 10, which is easier to subtract or add, right? So again, we have 48 base 8, sorry, 45 so 45 was base 8 is equal to expanding this is going to be to the power 0 to the power 1. It's going to be 5 times 8 to the power 0 plus 4 times 8 to the power 1, which is going to be equal to 5 plus 32. And that's 37. Right. And then the next one is 1102 to base 2 to base 10. Expanding, that's power 0, power 1, power 2, power 3. So then that becomes 2 times 2 to the power 0 plus 0 times 2 to the power 1 plus 1 times 2 to the power 2. Oh, sorry. This is 1 right here. Plus 1 times 2 to the power 3, which will be equal to 1 plus 0 plus 4 plus 8, which is 13. So the next part is subtract, right? So we have 45 to base 8 minus 1101 to base 2, which in base 10 is 37 minus 13, right? Because they're both in base 10. And that's going to give us 24. Next thing we do is convert the answer to base 7, because that's what the question asked for. So then we go back to base, number, and remainder. So we have the base is 7, the number is 24. 7 into 24, that's going to be 3, remainder 3, because that's 21. 7 into 3, that's 0, remainder 3. So since we have reached 0 here, we read the number up. So then that will give us 33 to base 7 is the final answer. So that's how you do that computation. And then the next question, it says 57 to base 8 plus 58 plus 57 to base 9 in base 8. So here how you'd go about it is change 57 base 9 to base 8, because one of them is already in base 8, so only one of them needs to be changed to base 8. So how to go about that? You do 57 base 9 to base 10 first, and then to base 8. So we have 57 base 9 to base 10. That's going to be the power 1, 0 to the power 1, which becomes 7 times 9 to the power 0 plus 5 times 9 to the power 1, which is going to be 7 plus 45, which is going to be 52. And now changing to base 8, we have base, number, and remainder. The base we're changing to is 8. The number we're starting with is 52. 8 into 52, that's going to be 6, remainder 4. 8 into 6, that's going to be 0, remainder 6. Since we've reached 0 here, we read our number from the bottom up, so then it becomes 64 to base 8. So what we are computing, so the second part will be the addition in base 8, right? So now we are computing 57 base 8 plus 57 base 9, which is equal to 57 to base 8 plus 64 to base 8. Now putting that in abacus form, that's 57 to base 8 plus 64 to base 8. 7 plus 4, that's 11, which is greater than 8. So the remainder is going to be 3. And then here it's going to be plus 1. 1 plus 5, 6 plus 6, that's 12. So here it's going to be 12 minus 8, that's going to be 4, which is the remainder. And then a plus 1 on the next spot. Then 1 plus 0, that's going to be 1. So then the final answer will be 143 to base 8. So that's how you do that. And then yeah, you can try the following exercise, simplifying by addition or subtraction the numbers in the given bases. The first one they have the same bases, then the second one they have different bases, so you have to convert either both to base 10, do the computation, then to the final base required, or if one of them needs to be changed, you only change one and then do the computation. And yeah.